Hey there, everybody. Jimmy to the Top Crane here. And this is rigging part two. Part two. And I know you probably can't read this stuff that's on this dry erase board. But I can read it from here. And fortunately for you guys, I can read. So I will read it to you. Um, Mainly, I put it up here on this dry erase board so it would remind me to point out some of this stuff. There's going to be a lot of information in this one. We're going to talk about the three most common types of rigging and where they would be used, some of the pros and cons of them, and then some of the appropriate rigging practices with them. And we're not going to cover everything, so please don't take this video and then go out and think, man, I know all about rigging, so now I can just go rig up stuff and take care of it. This just touches on the basics. All these videos are just going to kind of touch on the basics and give you guys a little information to work with, and then hopefully you'll be able to go out and do some more research of your own or get into a rigging class and apply it to your job or project, whatever you're doing. So first things first, we'll start off with synthetic. Synthetic is really popular. We use it a lot. We use synthetic more than we do wire rope or alloy chain. Okay, some of the pros to it. Non-conductive, non-sparking. It can be tailored, and what that means is you can have custom slings made. So if you need a sling that starts off with a loop at each top and then comes down to two slings shaped in a basket to pick a boat or an airplane or something like that, they can make it. They can make sling nets, you name it, and they can pretty well make it for you. However, all of that comes at a cost. So there's lots of common sizes and shapes and whatnot out there, but you can also have them custom tailored. They're also very lightweight versus their strength. So they're extremely strong for their weight, which in turn, I'll jump down here to this bottom, it makes it very easy to work with. It can conform to irregular shapes. So again, like if you're going around a boat, those nylon slings or those synthetic slings can hug the hull of a boat and help distribute some of the load out equally across the surface of the boat, whatever. I just use a boat as an example because synthetic slings are used a lot on picking boats out of the water and setting them in. And they can protect sensitive items. So again, back to the boat thing. But some of the cons, they cut very easily. So they have to be protected. If you're going around sharp edges, you have to have softeners in them. And your softener needs to be appropriately sized. They're also not abrasion resistant. So if you're dragging them around, letting them drag the ground behind you, you can damage them. So carry your nylon slings or your synthetic slings. Don't drag them over edges. All that stuff can damage them. And then we'll touch, they're sensitive to heat, UV, and chemicals. Quick to point out here, nylon is resistant to alkaline chemicals. So if you're going to be working in an environment where there's alkaline chemicals involved, nylon is resistant to alkaline, but it is not resistant to acidic chemicals. So if you were in a battery facility where they are using sulfuric acid, you would not want to take nylon slings in there. Nylon slings will get destroyed by acid. Even acid in the air can destroy nylon slings. And then a quick tidbit, nylon is prone to 10% stretching. That's at full capacity. What that means is if you start off with a 20-foot nylon synthetic sling and you take it clear to capacity, that sling may stretch 2 feet before the load comes off the ground. So nylon can stretch up to 10%. Polyester is resistant to acid, but it is not resistant to alkaline chemicals. So we'll go back to that same scenario of working in a battery plant. Polyester would be what you would want to take in there with you, because polyester is resistant to acid. However, if you're working in an environment with alkaline chemicals, do not take your polyester slings in there because they are not resistant to alkaline chemicals. And I was going to make a bunch of fancy slides and do this on a PowerPoint, and slides just aren't my thing. So, next up, alloy chain. And we're going to probably talk a lot about alloy chain because there is a lot to talk about with alloy chain. So, I forgot to mention, synthetic slings have a safety factor of 5 to 1. So, if a sling is rated, has a safe working load limit of 10,000 pounds, its ultimate failure limit is 50,000 pounds. That doesn't mean use it at 50,000 pounds. It doesn't even mean use it at 25,000 pounds. You have to stay under your safe working load limit when using rigging. So, synthetic is 5 to 1. Alloy chain is 4 to 1. So make sure that you stay under that 4 to 1 safe working load limit. The pros to alloy chain is it's very tough and it's very durable. That stuff is tougher than woodpecker lips. I mean, it's tough stuff. That's why they use it a lot in foundries, steel mills, precast situations, stuff like that. Alloy chain can also work in temperatures up to 1,000 degrees. However, you need to consult your chain manufacturer because typically your safe working load limit is reduced above 400 degrees. But you can use alloy chain up to 1,000 degrees. That's Fahrenheit. I'm in America, so everything will be in Fahrenheit. Repairable. Alloy chain is repairable. You can replace individual links. You can replace a master link. You can replace the couplers, hooks, all of that. Even if, say, you have a 2-leg bridle and one link in the center is damaged, you can have that repaired. They're corrosion and chemical resistant, and they're very easy to inspect. And we will talk about that in another video. That'll probably be part number 3. We'll do a video on rigging inspection, and I'll see if I can bring home 3 examples so we can learn how to inspect them. Cons: they're very expensive. Alloy chain rigging is very expensive. It's also very heavy, and it can cause damage to items being lifted. So, go back to the boat scenario. You would not want to throw an alloy chain sling around the bottom of a boat and pull it out of the water. Now, here's what catches a lot of people. I know people on their farms use log chains for picking stuff up or tie down transport chains. In the industry, grade 80, 100, and 120 is only approved for lifting. Transport chain is tested to a 3 to 1 safety factor for the transport industry. Lifting equipment on alloy chains is tested at a 4 to 1 safety factor, and grade 80, 100, and 120 is able to be elongated by 20%. The chain can elongate, each link can elongate 20% before the link fails. That's a standard that they have to test that stuff to for lifting equipment. And we're going to touch more on alloy chain after I get this board erased, because like I said, there's a lot to touch on with it. Wire rope. Wire rope is tested to 5 to 1 safety factor. The pros to wire rope is it's lower cost, so it's cheaper than chain. Typically it's a little more expensive than synthetic. It depends on your rope sizes and your configuration, what you're ordering. It's lighter weight versus alloy chain, but it is heavier than synthetic, typically, size for size. It's very strong for its size. It's flexible. It's abrasion resistant. It's corrosion resistant as long as you take care of it. And you can lubricate it, keep it from rusting, keep it out of the elements. Bridles can be rebuilt. So if you have a 2-leg wire rope bridle, you can have them rebuilt. The cons: low strength to weight ratio. So what that means is size for size versus some of the others, they're not quite as strong. Misuse, they are often misused, but misuse can cause damage, kinks, crushing, whatever, etc., broken strands. But wire ropes do get misused a lot, and we'll talk about some of that, and I'll show you how when I start drawing on this board. And fortunately for you guys, I got a bigger board so you can look at my terrible drawing in greater detail. Another con is a sling can't be rebuilt. It's not repairable. So if a sling is damaged, then you cut the ends and throw it away. Bridles, bridles can be rebuilt. That's two slings connected together on a master link with hooks at the bottom. Those can be rebuilt. You can reuse your master link and your hooks, but the section of wire rope between the two, not so much. They are subject to internal corrosion that is kind of hard to see if you don't take care of them, which leads us to hard to inspect. Max temperature on wire rope is 400 degrees. The minimum temperature on wire rope is minus 40 degrees. So if you're using your wire rope in situations where it's going to be exposed to temperatures over 400 degrees, you need to switch to alloy chain. And minus 40, I wouldn't want to work out in minus 40, but I'm sure there are people that do. Just know that your wire rope has to be sized accordingly because its minimum temperature is minus 40. So if you're using half-inch wire rope choker and you're taking it to capacity at minus 42 degrees, you are setting yourself up for failure. Okay, we're going to talk about alloy slings in a little more detail, because typically alloy slings have multiple pieces to them. I mean, you can have a continuous loop of alloy chain and have an alloy chain sling, but typically alloy slings are set up with multiple pieces. So at the top, you're going to have a master link. Hopefully everybody can read that. Just below the master link, there will be, and this, I'm going to draw a bridle. It'll be a two-leg bridle. Just below your master link is your sub-link. So why is it important to know this stuff? Well, if you're calling a rigging manufacturer and you need replacement, you need to replace your sub-links, but your master link's good, then they'll know what you're talking about. Below that is another link, and this is your coupler, or G-link. Just put an order over here. So the coupler or G-link is attached to the sub-link, and then from there it comes out to your chain. And I know that's way off, but at the bottom of your chain there will be another coupler, and then that coupler attaches to your hook. So master link's at the top, sub link is connected to the master link, coupler or G link right there is connected to the sub link, and then that connects the chain to the sub link, and then at the bottom of your chain is another coupler to your hook. And I know that looks like a J or a fishing hook, but it is what it is. Now, we're going to talk hooks quick, fast, in a hurry while we're on the subject of this. So there are hooks in the industry that do not have latches, and those are foundry hooks. So if it has a latch in here, or a fitting, if it's fitted for a latch, it will have a little eyelet here that you can put a pin through and connect your latch in it. If it does not have this, and it has no latch in it, and you know for certain that it is a foundry hook, it looks like a P, kind of. Foundry hooks do not have latches. So we're going to write that out here. So foundry hooks do not have latches. Also, foundry hooks are the only hooks that are designed to be tip loaded. So they have their full capacity clear out to the tip of the hook, which is right there. Typical hooks only have their full capacity in the bottom of the hook, in the throat of the hook, right down here. Foundry hooks can be tip loaded, and they're rated to their full capacity clear out to the tip of the hook. Don't confuse those. I get a lot of comments when we use our foundry hooks. I get a lot of comments. People like, "Hey, you don't have latches on your hooks." They're foundry hooks. They don't have latches in them. They were designed for foundry use. So make sure you know what you're working with as far as your hooks. We're going to talk about hook capacities as the load moves off center. So if your load is directly loaded in the center of the hook, your hook is rated for 100% of its rated capacity if the load is straight in the center. Now, if your hook is loaded a quarter off, so 1/4 off center, 86% of capacity. So if your load is a quarter off center of that hook, you're at 86% of capacity. If you are half off center, so half off center is 80% of capacity, so that's halfway between the bottom and the tip, 80% capacity. The next one is 3/4 off center. Your capacity is 70%. And then finally is a tip loaded hook. Point loading out there on the tip is 40% capacity. And I know this is a lot of stuff to remember. Fortunately, you can rewatch this. Now we're going to cover edge radius with chain. Hopefully this doesn't go over everybody's head. But if you have a piece that is square and you are throwing your chain around it, right here would be your edge radius. So if your radius is greater, that's not a 7, but greater than 2 times the chain diameter, and that's the link diameter. So here's your link. Your link diameter is here to here. So your link diameter is basically the thickness of the link. So if your edge radius is 2 times the chain diameter, the reduction factor is 1.0. So that means that as long as your radius around this edge is 2 times or greater than the chain diameter, you have virtually no reduction in your chain capacity. If your radius is greater than the chain diameter but less than 2 times the chain diameter, the reduction factor is 0.7. And then the last one, if your radius is less than the chain diameter, your reduction factor is point, don't miss that, 0.5. So say you got a link diameter a ½ inch and you go around a 1/4 inch radius, your reduction is 0.5. So your chain has a capacity of half of its safe working load limit. And this kind of stuff happens. And I know, like I said, this is a lot of stuff. And on my last rigging video, I had someone comment that it was the most mundane video or something like that. I mean, this is school work. I don't know any way to get excited about this. People, you guys asked to see it, so I'm doing it. It's not exciting, but it'll keep you from getting dead. And that's our goal, right? That's our goal in everything. Let's not get dead. Or get someone else dead. Okay, now we're going to go on to wire rope and edge protection. So if we have an I-beam and we come around it with a wire rope sling, and if we go around these sharp corners, there's a good possibility that I-beam will cut through that wire rope. So this radius, or the radius around the piece, has to be equal to or greater than 1 rope lay or 7 times the rope diameter. Okay, so the 1 rope lay, as we talked about this in an earlier video, we know that wire rope is comprised of rope strands that go around a core. 1 rope lay is the length of the distance from one point to another on the same group of strands. So as it comes one point on the rope, the strands wrap clear around, come back up to the same point on the rope on that set of strands. That is 1 rope lay. So if that 1 rope lay was an inch, then you could have a 1 inch radius here. However, if that 1 rope lay was 3 inches, then you would have to have 3 inches or more of radius on here. Now, a permissible way to soften that edge or to get your radius is to take pieces of pipe, and again, I'm going to probably botch this, but so if we have a piece of pipe, you can cut a slot in this piece of pipe on one side to accommodate the edge of this I-beam, slip it on there, and gain your radius. So, hopefully that doesn't confuse everybody. Typically, and if you did that, this is what you would end up with it looking like. You would have your pieces of pipe around here and your rope around it. This is going to be a long video. Probably going to be my shortest watched video too. We'll see. Something else that's often overlooked is the leg angle on your rigging. So if we are picking this box and say we're going to rig it with a choker, so it's going to come around the box. The leg angle is very important. So this angle here is the leg angle. This leg angle can be no less than 30 degrees. So a lot of times you'll see people as they're choking something and they're picking up on it, someone will beat down on this to tighten it up, or well, they'll beat down on this side. Let me erase that. So someone will beat down on this choker right here and it snugs it up tight against the top of that whatever you're picking up. Bad practice to be in. Do not do that. Here's why. This should be tightened. this should be snugged up before you start picking this piece up. Don't load this sling and then beat that leg down tight to snug it up. What it can do is actually cut the rope. It can cut the strands inside the eyelet, and also it can damage the rope where the eyelet is over the top of itself. So this should be snugged up before load is put on that choker. Also doing that, you can beat this down to the point that you're less than a 30-degree leg angle. And if you're below a 30-degree leg angle, your sling is not being utilized at its rated capacity. We learned earlier in video number 1 that as a choker, you've already got reduced capacity anyway. So as soon as you knock that down less than 30 degrees, your capacity is even less than what it was before. So this leg angle can be no less than 30 degrees. And this is going to be a 40-minute video. What else did I write down to talk about? Okay, we'll talk about chain grades real quick before we end all this. And I know I'm leaning pretty heavy on chain grades because it's often misused. So the different chain grades, I've got them written up here on the board, and I got a lot of information on here, and I'll go over it a piece at a time. But grade is based on ultimate breaking strength and is measured in newtons per millimeter squared. So yeah, there's that. You can Google it. So grade 30 is on the lowest end. It's lightest weight stuff. It's tested to a 10% elongation before it breaks. Also, it is rated for 300 newtons per millimeter squared, 43,511 pound force per square inch. And that's grade 30. It's used, I mean, you can use it for tie down, but it's not very strong. Then you go to grade 43, and all of this is in the tie down transport section. 3-to-1 safety factor is what it's tested to. Grade 43, they use it, they use it for tying down shipping containers. That's your standard run-of-mill log chain. If you go to a hardware store and say, hey, I need log chain, they're going to give you grade 43. It's 62,366 pound force per square inch. Also, I do believe that is tested to a 10% elongation before fracture. It may be 15%, but I think it falls in the 10% elongation factor. You guys will have to check that on your own. And then you go to grade 70, which is kind of a higher strength alloy transport chain, grade 70 transport chain. And some people even use grade 43 for transport chain. Grade 70, I do believe, is the industry standard for over-the-road transport chain. We've got several truck drivers that are subscribed to the channel. They can throw in comments if I'm right or wrong on that, but I do believe grade 70 is the standard for that. It is also tested to a 15% elongation before fracture, and grade 70 is 101,526 pound force per square inch. All of this is transport chain, whatever, general purpose chain. None of this for overhead lifting. No G30, no G43, no G70 for overhead lifting. And then I'll slide this over. And again, I know my penmanship sucks, but it is what it is. I'm 42, pushing 43. It's probably not going to change at this point. Probably only going to get worse. So lifting chain, 4-to-1 safety factor, tested to a 20% elongation before fracture. Grade 80 is the minimum for lifting chain, absolute minimum, with a strength of 116,030 pounds force per square inch. And then you go to grade 100. 25% stronger than grade 80 with 145,038 pound force per square inch. And then the new stuff on the block, which isn't very common. You can get it. It's typically blue in color. It's grade 120. It's 25% stronger than grade 100, 50% stronger than grade 80, with 174,045 pound force per square inch in strength. This is some stout stuff. You would have a tough time cutting this stuff with anything other than an abrasive wheel or a torch or plasma. A lot of times people will buy this and use it for chaining up gates and stuff with padlocks, because if I'm not mistaken, I think this stuff will break bolt cutters. So there's that. But grade 120 is so far, and like I said, it's fairly new. It is the strongest stuff out there for lifting chain. So again, anything on this side of this dotted line, if a truck shows up with rebar on the trailer and he's got this holding it down, do not use this for flying the bundles of rebar off the trailer. If you don't have grade 80, 100, or 120, then don't fly it off there with it. If you use this for lifting purposes, you open everybody around you up to potential disaster. And you also open yourself up to some serious liability. I can't stress that enough. And I had, in one of my older videos, I had a truck driver get on there and was getting after me pretty hard about it. And he was saying stuff like I was trying to make the crane industry out to be more dangerous than the trucking industry, and that something along the, it was almost harassment, but something along the lines that I was trying to make myself out to be better or something than truck drivers, and that's not the case. It's a different set of standards. It's a different set of rules. I'm no better than anybody else. And the trucking industry is no safer than the crane industry, and vice versa. What makes those industries dangerous is the people involved in them. So, again, transport chain, lifting chain. Grade 80, 100, 120, lifting this, tying stuff down. This gets you to the job. This gets it unloaded when it gets to the job. So with that, I'm going to finish this up on. We'll do part number 3. We'll start inspecting. I'll bring home some examples. I'll bring home some lifting chain. I'll bring home some synthetic, some wire rope. We'll go over the inspection, how to read the tags. Yeah, and then I don't know. We may even do a part 4 where we actually rig up some stuff and show you guys some different rigging techniques. That's going to be a little more difficult to do. I'll probably have to do that at work on my own time, but we'll see if we can make something like that happen. I know this stuff's monotonous, and I know for a lot of you guys this stuff is boring, but it was requested. There's people out there that wanted to know this stuff, and please don't think that I know all of this off the top of my head. I know grade 80, 100, and 120 is for lifting, and that stuff's for tying stuff down. All this other, well, and I know the safety factors and whatnot off the top of my head. This information about how the actual braking strength and stuff, I researched that. So I don't have that much crammed between my 2 ears. It's nothing more than what you guys can't research. But anyway, I'm going to get to editing this. It's 3:22 on a Saturday. I'm going to try to get this stuff edited and maybe uploaded tonight. And then Super Bowl's tomorrow. So you guys know what I'll be doing there. But anyway, enough rambling. Stay tuned for part 3. It'll probably be a few weeks out, maybe a month. With that, Two Top Crane is out.